You ready? Draw! All right, so of all the different types of two-sample testing that we can do, we are going to start with matched pairs because matched pairs is the easiest. And I'll tell you a spoiler alert, matched pairs actually acts like the one-sample test we've already done. So the example we're going to work with is premium gas versus regular gas. You've done it at the store, you go to the supermarket and you pull up to the gas pump and you see premium gas is expensive, regular gas is cheap, and you always buy regular gas because you're cheap. But one day you say, I'm just going to put some premium in my car just to see if it runs better. Come on, raise your hand. Who's done that? And I'm the only one raising my hand. That's really awkward. Okay, question. Does premium gas help your car run better? We're going to do gas mileage. And so I'm going to ask my friend who drives a Ford F-150 to drive for a week with premium gas and then drive for a week with regular gas. Here's his gas mileage. His gas mileage was better the week that he had premium gas. Does that prove that premium gas gives you better gas mileage? Well, not like that alone it doesn't. Let's ask some more friends. I have a friend who drives Mazda 3, and on premium gas, more gas mileage than on regular gas. Does that prove premium gas gives you better mileage? Well, I guess it's a little more evidence. Let's try an Aston Martin, and premium gas gave us better gas mileage. Okay, I'm starting to believe that maybe premium gas gives you better mileage. But for my dad's Lincoln Mark 7, premium gas actually gave him lower gas mileage. All right, but it's not a lot lower, and there's always random fluctuations. What were you doing that week? Are we talking highway or city? Let's fill out our table with a few other cars. Just to make it interesting, the Bud, which is my wife's favorite car, we'll say the premium gas was just slightly lower. The question we want to ask is whether the gas mileage on premium, on average, is higher than it is with regular. For both these data sets, there is an average and a standard deviation for them. And eventually we will talk about how to do two different samples that are separated. But for right now, this is not the way we want to do it. Especially these standard deviations are not helpful at all. You'll notice in the homework and on the exams I give these to you, but they are useless because we don't care what the gas mileage was for each of these premium vehicles. What we really care about is the difference between them. That's what matched pairs is all about. Matched pairs says this 20 is matched to that 25. It's not matched with any other number. It's specifically with the 25. And in this example, you can see why that's important. I don't want to compare the terrible gas mileage for the Ford F-150 to the Mazda 3, which gets great gas mileage. If I'm looking at the 40 and the 16 and the 17, it's going to seem like there's a lot of variability. But really, there's not that much variability. What I'm interested in is these differences. 25 minus 20 is 5. 16 minus the 14 gives us the 2. Here it's a negative because 17 minus the 18 is a negative 1, and that negative does matter. 0 because they were the same, another negative 1 down here. These are the numbers I want to test. They say, what's the difference from premium to regular gas? That's what I'm interested in. And this takes away the big variability between the 40s and the 20s. Matched pairs is actually a powerful way to do things because we've gotten rid of the variability that some cars have great gas mileage and some cars don't. I'm only looking at a data set of what's the difference between them. It's a very common question for students to say, how do I know if it's matched pairs? If it's matched pairs, you can tell me why the first car on premium gas matches the first car on regular gas. And the answer is yeah, they were both the Ford F-150, the same vehicle. And that makes them matched. Don't fall into the trap to say they all ran on gas. Well, that means 20 matches the 16 and 20 matches the 28. I mean, they all ran on gas means they all would match each other. It's matched pairs. This one and that one have to be the same. Another little trick that you'll pick up is you'll notice it has to be the same sample size. Is there a way to do the test if it wasn't the same vehicle? Yes, but we'll do that later. Right now it's matched pairs. Once I have these differences, I don't need the rest of that data set anymore. I will never use it. I'm going to make my hypothesis be all about this data set. And that's the trick with matched pairs. It looks like it's two samples. It acts like one sample of differences. So my hypothesis is going to be about a mu. And I like to put a little d here to remind myself I'm talking about the differences. And in the homework, it's going to require you to use the mu d. This is specifically the matched pairs mu d. And that matches the notation when we talk about the average for these guys. We're going to use x bar d for the average of these differences and SD for the average of the standard deviations. Now you might notice that if you took this minus that, you would get our x bar d. There's some rounding issues. I didn't carry out as many decimals on this as I should have. But averages work fine. You almost can't mess that up. But standard deviation, you would never get 2.22 out of this 8.7 and that 8.32, which is why I said you wouldn't be using those ever again. So our question was, does premium gas give you better gas mileage? So what should these differences be? If premium gas is higher, when we take that bigger number minus a smaller number, we should be getting positive values over here. So that's why this guy right here says greater than 0. This says, does premium gas, is the difference from premium to regular greater than 0? And here a less than or equal to 0. Set our alpha at 0.05. I think we have all the pieces. We can do this pretty quick. I'm going to put my x bar of the differences, which is 1.429, subtract what the null said, which was 0, over my standard deviation of these differences, which is 2.225, over the square root of, how many do I have? I have 7. That gives me a t-score of 1.698. A previous recording I said z. No, it's not z, it's t, because we got this standard deviation off the data set. But since I backed that up and recorded over it, now you have no idea that I said that. T-score, 6 degrees of freedom, gives me a p-value of 1.698. I want the greater than side because it's a greater than test. And 0.07021. So our p-value is big, bigger than alpha. We're going to fail to reject. So we were hoping to show the alternative. The alternative says when you did those differences, you would get premium gases better. The null says equals 0. Equals 0 means there's not any difference. If you subtract all these values and they average out to 0, then premium gas and regular gas are the same. We failed to reject, which means we can't prove the premium gas gives better gas mileage. Not with this data. It's possible that premium gas is better and we just need more data to show it. But from the cars we surveyed, it could be possible that you're wasting your money on that premium gas. Unless you have one of those special cars that actually needs it, because apparently some do.